Yeah, we're still on chapter 1. And 2 weeks roughly on each chapter. I'm just making sure my setup is good here. Check 1. All right. Okay, so why do we program? There are several reasons. Basically, we write programs to make computers useful to users. There are lots of things that go into creating a program. Programming is not easy, okay? It takes work, and it takes perseverance, and it takes logical thinking as well as creative thinking, all at the same time. So here are some of the aspects that we have to think about when we're creating a program. This is not an exhaustive list, but these are the main points. We have to think about the logical flow of the instructions. In other words, what step comes first, what comes next? Under what conditions do we execute certain steps as opposed to other steps? We have to think about the mathematical procedures. There's a lot of math involved in programming. Okay, you do have to be good at math to be a good programmer. So if you think your math might be a bit rusty, I strongly suggest that you take some time and go over to the tutoring center in the basement of the library and brush up on your math skills. We have to think about the layout of the programming statements. So again, which step comes first, which comes next, which statements are related to which other statements. And we should also think about how the code is organized so that it's easy to read for humans. Because generally speaking, the way programs are written today is with groups of programmers working together. There are very few programs that are written by just one programmer anymore. So you want to make your code that's easy to read, not just for your own benefit, but for the benefit of the other programmers. We want to think about the appearance of the screens. This is often called the GUI, Graphical User Interface. Let me type that out for you. Let's see here. So that's GUI. That a little bigger. I'll figure it out later. So GUI stands for Graphical User Interface. And this is often pronounced GUI, like so. Okay, so this is how the program will appear to the user, what they'll actually see. You want to make your program as easy to use as possible. Einstein is believed to have coined the phrase, make everything as simple as possible, but no simpler. So some tasks are simply inherently complex, and there's nothing you can do about it. But still, you want to make the program as easy to use as possible. Generally speaking, okay, it is the software programs that are the easiest to use, not necessarily the best programs that do the best in the market, that sell the best. Question?
Yeah, we were way past that. We were like around here, system hardware and stuff. I think we already talked about this. That's clear.
All right. Well, this is just a review then. You also want to think about making it easy to see for people who have different types of visual impairments, such as color blindness. So you want to use high contrast. Okay, you don't want to put, for example, blue text on a blue background. Even if it's a different shade of blue, it's going to be difficult to see, difficult to read. You might want to choose instead yellow or white or orange text to put on a blue background. Make it really pop, make it easy to see. Have good documentation and make it user-friendly with lots of help systems and manuals. Did we go over this slide already too? Okay, skipping ahead. CPU, we did this. Let me know when we get to something new. Right here? Okay, so different operating systems that exist. These fall in the category of what I would call the full operating systems that run on a full-size desktop or a full-size laptop computer. So Windows Linux or Unix, and the Mac OS. Windows is still the most widely used in the world, um, closely followed by Mac. And Linux or Unix is generally free, but more difficult to use and has less software available to it. So it's not as popular, but it is growing in popularity. There's also lots of free software that's available on all of these platforms, and those are growing in popularity as well. I'll also throw in that the price of a Windows machine is dropping very, very quickly. You can buy a full-fledged Windows laptop now for, I've seen them as low as $150, brand new Windows laptop. Yep. Uh, can you run two operating softwares at the same time? I'm going to say yes, but with caveats. For example, you can have the Mac OS installed on a Mac, and then you can run software that's called Boot Camp, which will actually run Windows inside of a window in the Mac operating system. So you can run that way Windows and Mac simultaneously. You can also do what's called dual boot, where you can install multiple operating systems on the same computer, but you can only run one at a time. That's also an option. And the newer versions of Mac are designed to run on Intel chips, which are the same chips that are in PCs. That didn't used to be the case. 6 or 7 years ago or so, Mac hardware was proprietary. And so the Mac operating system would only run on a Mac chip. But that's no longer the case. All the PCs, Mac or Windows, are using the same Intel x86 based chips. So you can actually run Mac on a machine that was designed for Windows. Some people call that Hackintosh. so these things do exist, and there's lots of different options of what you can do. And Linux and Unix, you can also run a window inside of Windows that's running Linux. So there's lots of different combinations. I have heard that when you do that, you sometimes run into trouble, especially with the hardware drivers, because they get confused as to what the heck they're running on. but there are fixes for that too. So there's lots of different options. And there's other types of operating systems as well, the mobile operating systems. Right? So what are some mobile operating systems that you're aware of? Android, iOS, Windows Phone, and there's one more that BlackBerry, yep. So out of these, iOS is currently the most popular, closely followed by Android. Windows Phone is not particularly popular at the moment, but I expect that will change in the near future. And BlackBerry is very uncommon, but it's sort of found its niche in high security type situations. But again, that's changing. It used to be true that the BlackBerry devices were more secure, had better security than the other operating systems. I'm not sure that that's the case anymore. And so what's nice about the language that we're learning in this class, Java, is that if you have the JVM, the Java Virtual Machine, installed on your device, and it could be a full-sized desktop, it could be a mobile device, you'll be able to run your Windows program on that device. You can take the same compiled Java file and run it on any of these devices, and it should work. There are single-user operating systems, which allow only one user to operate the computer at a time. And then you have multi-user systems, which allow multiple users to run programs at the same time. And here's an interesting gadget that does that. I like to talk about gadgets in class. I think it's a cool way to kind of bring things to life a little bit. So let me skip ahead to the product features here. I'm going to fast forward just a little bit to get to the aspect I wanted to talk about. So this particular laptop called the ASUS Tai Chi actually has two screens. There's one on the inside like a normal laptop, and then one on the cover, so that when you close the laptop, you have another screen. The screen on the outside is a touch screen. The screen on the inside is not. So they claim that this allows two people to use a computer at once as one possible use. So there was a good picture of it. So one person could be working, typing away, and the other person would have access to the touch screen, and they could be playing games or watching movies at the same time. And that runs regular Windows 8. So this is available now. They're around $700 or and up, depending on your configuration. Pretty interesting. So these are examples of single user systems, Windows 95, 98 ME, but newer versions of Windows can support multiple users at once in a variety of creative ways. And here are some examples of multi-user systems, including Linux, newer versions of Windows, and Mac OS. Now, application software is a software that runs on top of the operating system. This is the software that users interface with to do their work or perform their tasks or play their games or what have you. So here's some examples of application software. I'm going to assume that most people have used at least one of these, probably most of these: spreadsheets, word processors, accounting software, played a video game. Anybody ever not played a video game? Okay, good. So you know what a video game is. That's application software. Okay. There are many programming languages that exist that their purpose is to allow programmers like us to create programs with relative ease. Now, I say relative ease. It's still not easy, but it's much easier than it used to be. The first programmers had to program in zeros and ones. Okay, that was tedious. But now we can program in a higher level language that sort of almost resembles English, so it's much easier for us to understand. Then what happens is there's a compiler involved that takes and translates the code into something that the computer can understand. When we do this, we write a set of instructions that perform a task. That set of instructions is called an algorithm. So there are hundreds of languages in existence. There are millions of algorithms in existence. And whenever you create a new program, you are essentially possibly creating a new algorithm as well. So again, in order for the program to actually run, the algorithm has to be written in machine language, zeros and ones. We write in the higher level language, such as Java. Then a compiler eventually converts that into machine language that the computer can understand. Each CPU has its own machine language. Okay, that's why previously, if you wrote a program in, say, C++ or C or C#, when you compile that program, it creates a set of binaries, they're called, that will only run on that operating system. So if you compile it for Windows, it will only run on Windows. If you want it to run on Mac, you have to compile it again and get a different set of binaries to have it to run on Mac. And this is why. It's because each CPU has its own machine language. In other words, the same set of zeros and ones will not mean the same thing to one computer as it does to another computer. So skip that. Here's some examples of programming languages. Okay, there are hundreds in existence. These are just some of the most popular in industry right now. Of course, the one we're focusing on is Java. I think you'll find that the syntax in Java is fairly similar to a lot of these other languages. For example, BASIC, Pascal, C, C++, C#, Visual Basic, Python, JavaScript, they all have a very similar syntax. So in my opinion, once you learn one of these languages, picking up the other languages should be easier. It's not like learning a whole new language over again. It's just a slight variation on the language. If you do go into programming as a career, you will have to program in more than one language. I can pretty much guarantee that. You're not going to just program in one language for your whole career. Another important point to point out here, Java and JavaScript are different languages. They're not the same thing. Okay, so be an intelligent programmer, know the difference. In this course, we're learning Java, not JavaScript. If you want to learn JavaScript, I also teach a web programming course that covers JavaScript. JavaScript is exclusively for web browsers. Java can run on the web. It can also run independently. Their syntax, as I mentioned, is very similar, but they are different languages. Some of the key concepts in programming. You have keywords. Keywords are reserved words, if you will, that have a specific meaning to that programming language. You cannot change the meaning of those words. They're set, they're defined in the language. Then you have operators, such as mathematical operators, addition, subtraction, and so on, that do your basic mathematical operations. So some of the most familiar operators: addition, subtraction. What is the symbol for multiplication in most programming languages? Anyone know? The star, right. Its official name is the asterisk, and on your keyboard it's Shift 8. Okay, so let's call it the asterisk from now on. That is its correct name. Okay, so that's for multiplication. How about division? Anyone know? It's actually called a forward slash. Okay, so forward slash is for division. This is the backslash. Okay, so help you remember which is which, where they got their name. The forward slash leans forward, if you will, leans to the right, leans forward. The backslash leans backward, leans to the left. Okay, so know the difference. They are different symbols. If you put the backslash in your Java program, it won't do division. It'll give you an error. Okay, so it's a big difference. Again, know the terms. There's a lot of terminology here. You want to sound intelligent when you go for an interview. You want to make sure you know the terms. You want to sound intelligent so that you know what you're talking about, so you can land that job. I've heard news anchors mix up these symbols when they're, for example, giving you a URL to visit. They'll say backslash when really it's a forward slash, or vice versa. So use the right terms. There's punctuation that determines where programs start and stop, or not programs, where statements start and stop. And in Java, you'll see that we use a semicolon very often. All statements end in a semicolon. We'll get to that. We'll talk more about that in a moment. You have programmer-defined identifiers. So these allow you to create your own commands. And we're going to do that a lot in Java as well. There are strict syntactic rules that must be followed. So just like when you speak English or any other natural language, you have to follow the rules of that language in order to be understood. Same thing applies to programming languages. They have their own syntax. You have to follow the rules of that language in order for your program to compile and run. That's just how it is. You can't make up your own rules. You have to follow the rules of the language. You can create your own programs, okay, programmer-defined identifiers, but you still have to follow the correct syntax. So this right here is a very simple, complete Java program. Okay, so this will be our first Java program. Generally speaking, when you learn a new programming language, the first thing that you do is you create the classic Hello World program. You create a simple program that simply displays the message Hello World to the screen. So we're going to go ahead and enter this in. What I'd like you to do is to start up Dr. Java. So go to Start, find Dr. Java. The icon looks like a J with a stethoscope. You can also use another IDE if you choose to. We're going to use Dr. Java in class. JGrasp is another good IDE. Both of those are free. Other IDEs that I've seen students use include Eclipse or NetBeans. Those IDEs are more complex to use, so I don't recommend them for beginners, but they are more powerful once you get the hang of them. But for now, we're going to start with a simple IDE such as Dr. Java or JGrasp. So once you have your Dr. Java opened, I want you to go ahead and type this in, this program, starting with public, ending with this curly bracket. And what this will help you do is to recognize that the programs have to be typed exactly correctly. So in other words, you have to make sure you're using the correct symbols. Okay, this is a curly bracket. You know, this is a open parenthesis. This is a square bracket. They're different symbols. If you mix them up, the program won't compile. You also have to make sure that your capitalization, it matches this exactly. Okay, lowercase p in public. Most words start with lowercase. Notice that hello world here starts with uppercase. Okay, so just make sure everything is exactly correct. Go ahead and type that in. Give you a couple of minutes to do that.
Similar to our
Similar, yeah. Okay, I'm going to switch over to Dr. Java and load up the program. So don't worry if you can't see it right now. Here it is. Okay. So a couple things to point out that might make this easier for you. Most IDEs will color code certain aspects of your Java program. In other words, Dr. Java is aware of Java's syntax. So it does nice things for us. For example, this word public class as well as public static, those words are in blue. That means that those are Java keywords that Dr. Java is pointing out for us. Okay. Some of the other words are in black, so those are technically not keywords. Then notice that this part right here, the quotation marks, hello world, and then the closing quotation marks is in red. That's telling us that that's a string. That's known as a string. A string is basically a collection of characters in between quotation marks, like that. So those are some of the features that most IDEs will have. The exact colors that they use may vary slightly, and you can also configure them to your liking in the menu if you choose to. But by default, this is what Dr. Java uses. All right, looks like most people have that typed in. So now I'm going to show you how to save it. And it's very important that you follow these directions exactly, because the Java compiler, the way it's set up in these labs, will only find the file if you save it in the correct location. If you save it to the default location, it will not compile. The Java compiler cannot find it. And I don't know why they set it up that way, but that's how they set it up here. So to save to the correct location, go to File, Save As, click the drop-down box here, and what you need to find is under Desktop, find C, click on C, and then go to Users. Double-click on Users. Everyone with me so far? Once you get there, you should see your username as a folder. Right? So mine is m.colta. You should see your username there somewhere. Everyone see their own username? So double-click on that. So where we are now is in the users directory as provided by Hudson Valley Community College, and you each have your own directory that's for you to do with what you like, except anything illegal. So, so you can use this directory to save any files that you like. What I recommend is that you go to the Documents folder, which is also provided for you, and then I recommend that you create a folder for each class that you're enrolled in. Okay, and that will help you to organize your files. A really important skill, extremely, extremely important skill for anyone who wants to work with computers, is to have a good system for organizing their files so that you can find them later. That is absolutely a critical skill. So you want to have a good file organization system. You want to give your directories good and meaningful names. You want to give your files good and meaningful names so that you can find them later. That's absolutely critical. So under Documents, I recommend you create a folder for this class. I already have one here called CISS110. If you don't have one already, you can right-click in the white space and choose New Folder, and then change its name to, for example, CISS110. Again, I recommend you do that for each class that you're taking. Each Each course has its own folder. Then double click on that CISS110. Then what I recommend is that you create a folder for each module. Okay, so I already have a folder here called Module 1. So I recommend you do the same. This is just a recommendation, okay? If you have your own system that works better for you, you can go ahead and do that. But if you don't have your own system of organizing and finding files, I strongly recommend that you do exactly as I'm recommending here. And then go into Module 1. And then for the file name, you want to type this exactly. Hello world, capital H, capital W, .java, no spaces. Okay, so you want to type that as the file name. Hello world, capital H, capital W, .java, no spaces. Then for files of type, you want to make sure you choose Dr. Java source files. Okay, once you have that, go ahead and click save. In my case, it already exists. In your case, it should not already exist. Now the file is saved in the correct location where the Java compiler can find it. So what we're going to do now is go ahead and compile it, make sure everything worked. So there's a nice button here right in Dr. Java that says compile. You can click on that. And if everything went smoothly, it should say compilation completed on the bottom. If it didn't, I'll be around in a moment to try to help you out. But see if you can find your error. You know, look through the file, what you've typed here, make sure everything is exactly the same. Then once it's compiled, once it says compilation completed, then we can run the program. There's a nice run button over here on the top as well. So you can click on that, click run, and you should see these words, hello world, show up in green in your console. And if that worked, congratulations, you just wrote your first Java program. Click on the run button. Yep. Oh, line numbers, that's a setting. I believe it's under edit, preferences, display options, show all line numbers. That's a very good question. In fact, I recommend that everyone turn that on. Turn on the line numbers, because if you get a compiler error, not if, when you get a compiler error, those line numbers will help you to see where the error is located. Okay? So I recommend that everyone turn on line numbers in Dr. Java. So again, you go to File, or excuse me, Edit, Preferences, Show all line numbers. Check that on. So, and one of the things that's nice about the way Hudson Valley has set up your accounts is that when you set up Dr. Java the way you like it, it'll remember it. So when you log on to a different computer on campus, all your settings will be the same. That's kind of a nice feature. All right, so I want to make sure that everyone has that working correctly. Does anyone have issues? All right, I'll be around to help you. If you finished this, then what you can do is you can look at the notes and read ahead, or if you like, you can tinker with this program, change it around a little bit. For example, change the message to say something else, or put in a couple more commands and just play with it. The best way to learn the program is to play program. All right, go for it. I'm going to help a couple students, and I'll be back. almost the same. In some fonts, they look exactly the same. Really bad design, but they're different characters. All right, everyone's good now? Excellent. So that's the general process that you will go through to create your Java programs, then compile them, and then run them. Now, what I want to show you is the different files that the Java compiler creates and or Dr. Java creates. So if we right-click on the Start menu and open Windows Explorer, okay, another terminology issue here. Know the difference between Windows Explorer and Internet Explorer. Okay, they're different. Internet Explorer is for exploring the World Wide Web. Windows Explorer is for exploring your internal storage, whether it's your hard drive or your solid state drive, okay? So, or your CD drive, etc. So, know the difference. Internet Explorer is for the internet. Windows Explorer is for exploring your secondary storage. So we can find that file in the same location. So click on C, Users, your username, then Documents, and then whatever you called it, CISS110, for example, then Module 1. And you should see that there's actually 3 files there, not just the one that we saved. So here's what they are. This is the file that we actually created, okay, hello world.drjava. And this is actually a fairly plain text file. We can, for example, open it with a plain text editor such as Notepad, and we can read it, and it looks the same. So a Dr. Java file is essentially a text file with the .java extension, okay? So that's the file we created and saved. Then you'll see the same file, but with a tilde after it. That is a backup file, okay? Dr. Java will periodically save your work automatically, roughly every 10 to 15 minutes while you're working, and it will save it with this tilde after it. Most other application software packages will do this as well. So for example, if you're working in Word, you're working on your paper, it will save, depending on the settings, every 5 to say 20 minutes as you're working, and it will save it with the file name and a tilde after it. Okay, so that's a really nice feature that it saves a backup for you, and you can also open that with Notepad, and it will look the same, assuming that the versions match. So there it is. Yes, question?
Can we access the C drive remotely? Like if we're working on something new and save it to the C drive?
Yes, I believe so. I believe you can get into it through Wired. I'm not exactly sure how, but I believe you can. Yeah, so you should be able to. But test it. Don't rely on it. Make sure you test it. Know how to do it. If you have trouble with it, the ITS help desk can help you with that. Another question? Yep. Yours. So yeah, you have to choose Notepad. Yeah. Go ahead. It could be that the program just wasn't open long enough to do an automatic save. Don't worry about it. Okay, so that's these 2 files. Then you have the .class file. The .class file is created by the Java compiler. This is essentially the compiled version of the program. So that .class file takes our Java file and turns it into sort of this middle ground file. And we can look at that with, say, Notepad. But you won't be able to read it. It's a bunch of gobbledygook. Okay? So this file is not human readable, as it's called, but it is machine readable. The JVM, the Java virtual machine, can read this file. Remember that with Java, you have to have the JVM, the Java virtual machine, installed on the computer in order to run a Java program. So we can take this class file and put it on any computer that has the JVM installed, And the JVM will do what's called interpret this file, which means it will convert this from this sort of middle ground file to a machine language file on the fly while it's running. So this .class file is platform independent. This will run on any machine that has Java installed. Okay, so those are the files, the main types of files that you need to worry about with this class in Java programming. All right, so .java is raw, the .class is compiled. Anything with a tilde after it is generally a backup file. Yes? I'm sorry, say that again. Yeah, if you opened it in Notepad and edited it and saved it, yeah, that would change it. You can use Notepad as your IDE if you want to. In fact, they used to do that here a couple of years ago, but I don't recommend it. It doesn't have any of the nice features that Dr. Java has. Okay, Dr. Java is free. You might as well use it. For example, Notepad is not going to color code your code like this. Notepad is not going to have a compile button and a run button right there on the interface, right? You can do it. You'd have to type it in. You'd have to make sure you have your commands correct on your own, basically. And then you'd have to use the command line to actually compile and run your code. You'd have to type the commands in, which you can do. You're welcome to do that if that's what you want to do. But if this is your first time programming, I recommend that you use one of these, Dr. Java or JGrasp. Any other questions? Yes.
With this program, I guess, public class and local, like, is that how every program will start off, like public class main?
Pretty much, yes. Every class is going to start with that public class and then some name that you get to choose. You name the program appropriately. The preferred naming convention for the name of the program, the name of the class, is that you capitalize those. Okay, so if it consists of two words like this one, you capitalize each word, but you cannot use spaces. And it's also recommended that you use this notation instead of putting an underscore. You could put an underscore, it would work, but this is preferred. And then for other things that you get to choose, for example, this is actually a variable called message. It's of type string, but this is a user-defined variable name. It's lowercase, and that is the convention for variables, that they're always lowercase, okay? Another phrase that you'll see in every program is this right here. This command, public static void main string args, with this exact syntax and punctuation, will be in every Java program. So you want to memorize that, get to know it, tattoo it to the back of your eyelids, okay? It will be in every single Java program. And then, this part will change depending on what the program is going to do. Another important aspect of programming, which this example actually doesn't have, is comments. Comments are simply notes to the programmer. They do not affect how the program runs whatsoever. They're simply for the programmer to keep their thoughts organized. So this is one way to create a comment. You put 2 forward slashes before the comment and then type whatever you want. Notice that it's in green. So Dr. Java recognizes that as a comment. It's in green. And again, all this is a note for the programmer to themselves or to other programmers. It has no impact on how the program operates. Question in front.
When you say to memorize the public stack void and all that, what exactly is the function that brings out?
We'll talk more later in the course about the details of what this does and what all these words are for. It's too much to go into right now. For now, just memorize it and know it has to be in every Java program. But we will get there later in the course, I promise. Oh, for those who are listening to the recording, the question was, what does this memorized line do? This public static void main string args, what does it do? And the answer is, we will cover that later in the course. For now, just memorize it. So here are some of the keywords in this program, as I talked about, which Dr. Java highlighted in blue nicely for us. These are keywords that have a specific meaning in Java. So they can only be used for that purpose. You cannot create your own variable named public, for example. Okay, it's a keyword, and you can't do anything else with it other than what Java says you can do with it. There actually aren't that many keywords, roughly 25. Okay, that's it. So when you're creating your variable names or your class names, you have to avoid those keywords, but there's only about 25 that you have to worry about. So it's not so bad. Keywords are lowercase, and remember that Java is case sensitive. You may have heard that phrase, but have maybe never seen it written down. Case sensitive. Okay, what that means is whether the letters are capital or lowercase matters. Okay, so if you type a variable name one with a capital letter in it, and then later try to use that variable name but type it all lowercase, it won't recognize it. To Java, it will be two different things. So you have to make sure that your capitalization matches. Case sensitive. And again, keywords cannot be used as programmer defined identifiers. Semicolons are used at the end of statements, but not all lines in a Java program are statements. So if we look back at this code here, we have two statements, 1, 2. They have a semicolon at the end, but there's no semicolons anywhere else. Okay, so this line is, while required for the program, is technically not in the category of a statement. Same with this line. Again, required for the program, but technically not called a statement. And we are out of time, so we're going to go ahead and end there. Thank you very much. Remember that you have lots of work due Thursday, so my recommendation is that you pretend it's due today or tomorrow and get it done. Have a great day, and I'll see you tomorrow.